Alright, this is a little section of your Chapter 16 notes, Part 1, about atomic history. Okay, so the atomic model has a lot of phases that it went through, and you guys are going to do an atomic timeline to look at some different phases on your own, but this is just kind of the short and sweet, kind of what I want you to know for sure. First, it started out with Democritus, with about 400 BC. That's where we're going to start our journey. 400 BC. And he said that atoms came up, so this is the first time that we brought up the word atoms, make up all substances. So, you know, of course, we're talking about the word elements. So they and of course at this time they didn't know the word elements. Again, we're talking back before the term element even was around. So we have made up these substances. And then the funny part is, at the same time, though, 400 BC, this famous guy, you might have heard of him, Aristotle, he said that Democritus was wrong. He said that there wasn't these things that were called atoms. That matter was uniform throughout, and it was not composed of anything smaller. So he basically said Democritus was wrong, that, you know, he was basically like, whatever, you know, you are absolutely wrong. You can't be right. Okay? And this was accepted for 2,000 years. So what Aristotle believed, 2,000 years, basically saying that Democritus is wrong. You know, of course, Democritus had some followers, and, you know, some people believed him. But, you know, overall, they didn't believe that. So 2,000 years later, basically, give or take, you know, there are models that came along the way that changed that thought. But kind of the big turning point, eventually we get to the point where we have John Dalton's model. John Dalton, 1800s, he was an English scientist. He was the one that gave proof that basically that atoms existed. He was the first one that really said, hey, here's an atom, hello. And his model was basically a solid sphere. And the way I think of John Dalton's model, you can see a picture of his model right here. I think of it like those chocolate balls that you get at Easter time that are completely filled chocolate. They're solid. They're filled to the, they're filled to the complete, you know, total chocolate all the way through. And that's what he believed atoms were. They're just all atom. Nothing made up inside at all. Of course, we know that that's not true. And then there were models along the way that changed that, and you'll see some of that. There was the plum pudding model, which we might talk about that in class a little bit, and I'll show you that. But today's atom, of course, representative, and about 1926 was when the current atom was kind of put together. We call that the electron cloud model, where you have this center of a nucleus and the outside electron cloud where all these negatively charged electrons live. Okay. And so we have atoms. We know that atoms make up all elements, and so that it's the identity of the element itself, in the sense of that it's the smallest piece of matter of that element. Makes protons. The atoms are made up of protons, neutrons, and electrons. It has a nucleus, and the nucleus itself has a positive charge. The nucleus, as I just said, has a positive charge. The positive charge is because of the protons. The protons are positively charged, and they're different for each atom. They have different numbers, so meaning that each atom will have a different number of protons. So a carbon atom will have a different number of protons from a nitrogen atom. And that's what gives each atom its individuality, in the sense of what makes each atom different. The nucleus also holds neutrons. Neutrons have no charge. Then you have electrons. Electrons, of course, so we have the nucleus, so this is your nucleus, and then, of course, outside you have all these little electrons outside the nucleus. They are negatively charged. There's nothing smaller than the electron, in the sense of when we talk about protons, neutrons, and electrons. So of protons, neutrons, and electrons, the smallest is an electron. It's considered the most basic particle. Okay. Now, for protons, and I'm going to make sure I definitely underline this, protons and neutrons are made of quarks. So notice it's not electrons. Electrons are the smallest things that you have there, but protons and neutrons are made up of quarks. There are 6 scientifically confirmed. 3 quarks together makes 1 proton. 3 quarks together makes a neutron, and they're 3 different quarks. Scientists are still trying to figure out what 3, and they give them like weird names. They're saying like an up quark, a down quark, and I don't remember the other ones, but it's something weird like that, make a proton. And then, you know, like a down quark, something like that gives you a neutron. It's something weird like that. How do they find quarks? Basically what they do is they take and they accelerate particles really, really fast. And then when they accelerate them really fast, they use these electric and magnetic fields basically to accelerate them. And then they smash them together. And what happens is that they break apart. And then they basically look and see what's left over after the crash. They kind of study the crash scene. And this is not easy at all. And basically, because we're talking about really, really small things. I mean, we're talking smaller than, you know, protons and neutrons. And so basically, the scientists found the first 5, and then they hypothesized that there was a 6th because they figured that they come in 3s. So, and then a couple more things about the electron cloud, because we know we have a nucleus. We know that we have a nucleus, okay, and then we have all these electrons outside the nucleus. The electron cloud is the place at which electrons are most likely found. It's 100,000 times larger than the diameter of a nucleus. Here's how I think about it. You're talking about like a peanut inside of a football field. The peanut is the nucleus, and the football field is the where the electrons lie. That cloud where the electrons can be is a huge area of space. Each electron cloud is much smaller than a proton. It's impossible to describe the exact location of electron, meaning that you can never tell where an electron is and tell how fast it's going at the same time. And this is due to its mass and its speed. That's called the Heisenberg uncertainty principle. You might have heard it. If you ever watched Big Bang, they've brought it up a couple of times. It's kind of like, you can never tell where exactly the electron is and see how heavy it is, or know how heavy it is and know where it is at the same time. It's impossible to know. So that's kind of my short little suite on atom history and a little bit about the atom.